All right, so we have, according to the Bureau of Labor Statistics, this is in 2015, statisticians earn an average of $84,010 a year. Suppose that the current annual earnings of all statisticians have a mean of $84,010 and a standard deviation of $20,000. Find the probability that the mean earnings of a random sample of 256 statisticians is. Okay, so this is actually not from 7.5, 7.6. This is from the earlier stuff. Okay, so from 7.1 through 7.3, or 7.4, I believe. Will we have a problem where we will have to use the population instead of the sample? Well, that would be in chapter 6, so then it would just tell you the population, or that it is a population. So you wouldn't have to do anything special with the standard deviation to answer your question. Okay, so for this one, let's see what we have. We have a sample size of 256 statisticians. Okay, we have a mean of $84,010. Okay, now we are given a sample size. So if we kind of recall back to the earlier stuff in this chapter, when you're given a sample size, you find the standard deviation of your sample, which is standard deviation of X bar. Yeah, the packet printed weird. So yeah, it's in the middle of the packet. Thank you. Okay, so the standard deviation of X bar is given to us by the population, sorry, not the population, the standard deviation of the population over the square root of the sample size. Okay, so for this problem, the standard deviation of X bar is going to be the standard deviation of the population, 20,000, over the square root of 256. Okay, so let's go ahead and do that. So 20,000 divided by the square root of 256. So 1250. Okay, so then let's do this problem. So we want the probability that the earnings from the sample are between 81,400 and 82,600. So we need to standardize both of these. So the formula for Z here is the same. It's X bar minus the mean over the standard deviation of X bar. Okay, so we know we're using this is not a proportion because it's not given to us as a percentage. Okay, we know it is a sample, okay, a sampling distribution because it gives us a sample. If it just said find the probability and it didn't say there was a random sample, then you divert back to chapter 6. Okay, so chapter 6 is just X minus the mean over the standard deviation. You don't have to do anything with the sample size here, okay? So that's this one. Population proportion for p hat, that's when you're given a percentage, okay? This doesn't give us a percentage. So that's the main difference there. And on the test review, kind of go over that, which one do you use which. So here our X bar, first X bar is 81,400. And then we subtract 84,010, our mean. And then we're using this new standard deviation of 1250. So let's see. So there you get negative 2.088. And then let's do the Z-score for the 82,600. Okay, so this is going to be 82,600 minus 84,010 divided by 1250, so negative 1.128. Okay, and then we're going to put this on our standard normal curve. Whoa. Here we go. Okay, so -2, go about right here. And then -1.128, maybe about right here. And then this is the area that we're looking for. So in each of these problems, we're still using the same calculator. Okay, once we get everything standardized, we just have to figure out what information we're given so that we know which standard deviation calculation to use. So this is -2.088, -1.128. And that would be 0.1113. Okay, so roughly 11% of people in this random sample have a salary between $81,400 and $82,600. That's what that's telling you there. Oh, these are all came down as A. So this would be B, less than 80,000. So again, standardize this score. Okay, so 80,000 minus 84,010 over 1250. So that gives us -3.208. And then we can put this on the normal curve here. Let me see if I can pull a normal curve up. Hold on. Yeah, there we go. Okay, so there's my normal curve. -3.208 is going to be way over here, and then it's less than that, so it's like really, really tiny little point right there. That's what we're looking at. This area right here. Sorry, it's not P, it's X bar. Okay, that's this little area right here. And so we're going to go in our calculator, normal CDF. And then we're going to have -99, -3.208. So that is going to give us, okay, 6.7 e to the -4. So that is in scientific notation. So it looks like this. So to get that actual number, you take this 6.7. This means to the left 4 decimal places. So 1, 2, 3, 4. So 3 zeros. So then the answer there, if I rounded that, that would be 0.0007. So that's your answer. So the probability that someone in the sample makes less than $80,000 is, if I change that into a percent, 0.07% or 0.0007 is the probability there. And then the probability that someone makes greater than 100,000 in this sample is, let's see. Okay, so 100,000 minus the mean over our standard deviation here. So 12.792. So I can't even put that on my normal curve. So on my standard normal curve, if I were to put this on here, Okay, that is way over here. So what do we think that probability is going to be? Yeah, it's going to be 0. Okay, and if I put that in my calculator, I would go normal CDF, 12.79299, and I get 9 times 10 to the negative 38. So if I went and I tried to do the scientific notation for that, I'm getting 0. So we say the probability that, I keep saying P for probability, but that X bar is greater than 100,000. It's the P of X bar, there we go, is 0. So the probability is 0 because it's such a small sample size.